Hi everyone, I wanted to talk to you about this word problem as well because it's very interesting and it's actually pretty good and you can use it every day if you go to a store and you want to know or you want to know how much your friend paid for something like that. A vendor sells hot dogs, chips, or bags of chips, and drinks. A customer buys 2 hot dogs, 5 chips, and 2 drinks for $10.50. So now if we notice that they gave us quantities, 2 hot dogs, 5 chips, 2 drinks, not dollars. And then when we put all of those together, because the customer bought all of these, he paid $10.50. So that might be confusing because if someone said, well, 2 hot dogs plus 5 chips plus 2 drinks, that's $10.50. They might get confused because they will think, oh, that's like money and those are quantities and I shouldn't put money and quantities in the same equation. However, we have to realize that I don't know the price of a hot dog. I don't know the price of a chip or bag of chips, and I don't know the price of a drink. So now what represents the money are my variables. Because if a hot dog is $2 or $3 and I got 2 of them, so I do 2 times the price of that hot dog and I'll get the money I paid in total for the 2 hot dogs. So each one of these terms represent actually money. The numbers represent quantities and the variables represent the unknown money amount or the cost for a hot dog, a chips, or a drink. And when you multiply 2 times the price of a hot dog, so I say I got 2 hot dogs, each one of them is 3, so you do 2 times 3 and you get 6. That's actually $6 that you paid, right? So each one of those terms represent money. So we're pretty good with that setup. Now the second sentence would say, the price of 1 hot dog is 50 cents more than the price of 1 bag of chips. So I think I should have inserted bag here so it doesn't make sense. 1 chips. I don't know. I think I probably should have written 1 bag of chips, but that's okay. Alright, so we have to realize here that they are saying that a hot dog is actually 50 cents more, its price, which we agreed that those variables represent costs. 1 hot dog is 50 cents more than the price of 1 bag of chips. So this hot dog is actually already more. I'm going to use an arrow that's pointing up. So it represents that this hot dog is actually 50 cents more. It's more expensive. Now, my equation must include an equal sign. That equal sign was not given in the problem. The problem says more, or that sentence says more. It didn't say equal. Now, we have to think, how do we make them equal? If the hot dog is 50 cents more, and I want to make the bag of chips actually equal to it, then I should increase the bag of chips by 50 cents. Or I can decrease the price of a hot dog by 50 cents. So I can add 50 cents to my chips, or say H minus 0.50, so that they're equal. Because that equal sign is, I inserted that. I'm trying to make them equal so that it's an equation. Alright, if we continue, it reads, 1 drink is $1.75 less than the price of 2 hot dogs. So I write them both. And 1 drink is $1.75 less than the price of 2 hot dogs. So I'll give it a down arrow. So don't do it fast and write D minus 175 because it says 1 drink is 175 less. So I want you to think about it a little bit. 1 drink is 175 less. It's already minus 75 from the price of the 2 hot dogs. That's already the case. Now my situation is I want to make them equal. So to make them equal, it's either you subtract the $1.75 from the 2 hot dogs so that the price is pretty equivalent, or you can add the $1.75 to the drink price. So either way is fine. Either way is fine. That's a point. That's okay. So now we have 3 equations, but you know what's interesting about this is that you have 2 equations that don't have all 3 variables. See, if one equation didn't have one of the variables, it's fine, because I can use the other 2 to cancel the same exact variable so that I can solve. However, one of the equations, 2 of the equations in that case, are missing variables. So I'll show you what to do so that you would know how to solve it and finish that and complete it and bring it to class tomorrow. Okay, so those are the 3 equations that we figured out in the previous slide, and all I did is I just rearranged C and 50 cents. They were switched, so $1.50 was here and C was here, but I just rearranged them. Similarly with the 2h minus 175. If you took notes from the previous video, you'll see those are the exact same equations that we have. So now what we need to check for here is that can we substitute anything in those 2 equations that are causing us trouble because variables are missing from them. And the answer is yes. I have h is equal to c plus 50 cents. So c plus 50 cents is equal to h. So in that second one, I can take away that h and put c plus 0.50 because h is equal to all of this. So what I will do is I'll take those 2 equations and try to work with those first because they have missing variables, both of them, which is kind of a problem. So what I'll do is I'll take that equation right here, equation number 3, and I'll say g equals 2. Instead of h, I'll put c plus 0.50 because that's my h minus 1.75. So that's my equation right there. And all I did is I substituted h for c plus 0.50. Now we can always distribute. I'm trying to get another color. So we can always distribute right here. So d equals 2c plus $1 minus $1.75. Agreed? So now if we combine like terms, let me move that up a little bit so we'll have more space. Okay, so we'll have d equals 2c minus 0.75 or 0.75. My points. Okay. Well, now I have 2 important things. I have this equation on top right here. A hot dog is c plus 50, and a drink, I got it as 2c minus 0.75. Now, in that case, I represented 2 of my variables, which are, I can circle them, my hot dog and my drink. I represented both of those variables by an equation that has c in it. Only c. Doesn't have any other variables anymore. Now what I need to do is I need to plug back what I know in the first equation. So I'll say 2, and instead of h, I will use c as my only variable in this equation, plus 5c, that I won't change, obviously, 2 times, instead of a drink, I'll say 2c minus 0.75 or 0.75, and that whole thing is equal to, keep moving them so that we will have more space. That whole thing is equal to 1050. Wow. So now all I did is I substituted what I know in the second equation. Since a hot dog is c plus 50, the second equation, I can get rid of that hot dog and put c plus 50. And that's what I did, combining like terms. By doing that, I got the price of a drink in terms of chips. So now I have hot dog represented by an equation in terms of chips, and drink is represented by an equation in terms of chips. And by doing that, I have an entire equation that has chips only. That will allow me to solve for chips. As soon as I get that, I can plug it back and get the price of a hot dog, get the price of a drink, and I'm done. And this is what they need. Now, it's very important that you write your answers in complete sentence. So I can say C equals that, and D equals that, and H equals that, but I don't want to just see final answers. I want you to write the price of one chips, or one bag of chips, equals to da 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 da. The price of one hot dog equals to da 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 da. And the price of one drink is equal to da 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 da. Or instead of price, you can use cost, since the problem was phrased like that. Alright, so make sure that you write your answers in sentences and bring it to class tomorrow. Don't forget there's another video on coffee beans, and or coffee mixes, and another video on planes above, and also the answer sheet key is given to you as a PDF or embedded document. Alright, I'll see you tomorrow in class.